This video is our intro to graphing rational functions. We're going to be talking about vertical asymptotes. So our x equals. These are what our rational functions will look like. So what you're going to have are these asymptotes, vertical and horizontal. There's two vertical asymptotes and one horizontal. This one has a slant asymptote. In fact, it's linear. It's a y equals mx plus b. Here's another one like that. This one has a vertical, and you can't see the horizontal, but it is the x-axis itself. That would be y equals 0. So when we start these rational expressions, the first thing you're going to do with this rational function is factor it. So we have to turn the top into this and the bottom into this. You want a fully factored form, and then you're going to look and see if you can reduce, and nothing cancels. This is why we want to factor it. So what happens is these two denominators here, these are what are giving us our vertical asymptotes. So if you remember, denominators here cannot equal 0. So that means our x here cannot be 3 and our x cannot be negative 3. So how that translates into graphing is these become your vertical asymptotes. This becomes x equals 3 and x equals negative 3. So in order to find your vertical asymptotes, you're going to take the bottom, which is our bad thing, set it equal to 0, and solve, just like we did here. And so this becomes x equals, the one is on the left is negative 3, and x equals 3. These are our vertical asymptotes. They are vertical lines when you graph them. And that's it. This is what we're starting with, just vertical asymptotes right now. So we're going to look at our functions, and we're going to decide what is the vertical asymptote only. That's it. So flip the page, and here are a bunch of problems for us to try. There are 3. So I'm going to do the first one. So here our denominators cannot be 0. So that means x cannot equal negative 2, and x cannot equal 5, which translates into a vertical asymptote at negative 2 and a vertical asymptote at 5. So I want you to go to negative 2, and you draw a dotted line, vertical. And I'm using red because these are numbers the graph cannot equal, the function cannot equal. They are undefined values. So 1, 2, 3, 4, 5. And then you do another vertical. That's all I want right now, just vertical asymptotes. So before I have you try the next two, I want you to see this with Desmos. So I've got our rational function here. You can see that it says minus 4. That would be plus 4. So we have a vertical asymptote at negative 4. This one says minus 5, so we have a vertical asymptote at 5. You can see the sign just changes. And so if I change our function to 2, negative 2, we now have a vertical asymptote at 2. Now it's at 4, 3. I can move that back to 5. Let's move it over to the positive. See? So now you can see it's minus 2, minus 5. Our vertical asymptotes would be 2 and 5. So you're just looking at the bottom. That's it. The bottom numbers give us our vertical asymptote. And if we move it over here to minus 5, you can see it's now plus 5 here. And we have a vertical at minus 5. That's it. So whatever your denominators are in factored form, that's your vertical asymptotes. The other numbers, if I modify them, don't change the vertical asymptotes. You see that? Remember that top number just vertically stretches it as it gets bigger, and the bottom number vertically compresses it. The function's it's changing, but the vertical asymptotes are where they are. They are not going to change because that is our undefined values, and that's what our graph approaches. So you can see our graph is approaching from the left going up, approaching from the right going down, up, down. So they're going to have importance. So let's go back to our notes. So I want you to look at each of these, and I just want you to tell me what is the vertical asymptote and then to graph it. So hit pause now and try it. So this is what you should have gotten. You should have got a negative 4 and a positive 4. Negative 4 for the first factor, positive 4 for the second. And so those should be your vertical asymptotes here and here. And then you should have got negative 3 and positive 5 and then graph them. And so after you graph these, what I'd like you to do is label them. We call that one x equals 5. And even if you put the other one down here, it's fine. But label the graph, because remember the vertical lines are x equals. That's why we are saying x equals. X equals 5 is our first vertical. And so what's going to happen now in the second part is our graph is going to approach these things. We don't know from where. We will talk about that later. But they are places that it approaches. Thank you.